Dankie. So what we've done is we've developed a vertical farming solution specifically for the production of leafy greens. And so why did we see that there's a need for that? So we realized, and it's common knowledge, that there's challenges faced by farmers and retailers in the leafy green space. So here are the challenges. So a lot of these things are common knowledge, but we've been asked to speak about it, so we'll highlight them as again. So when you plant leafy greens, you typically have plants which don't grow like a tomato or a cucumber already in a vertical vine format. So your leafy greens are typically very short, stocky plants. And therefore they take up a lot of real estate. And this large real estate then makes it less attractive to do this in an enclosed environment or in a greenhouse. So the reason that you then end up farming outside also then pushes you out into the arena where you have no control over the climate. So you are at the mercy of the weather patterns and the seasons and so forth. And the high demand for a large amount of area then also means that invariably you're not going to be in an urban or peri-urban environment. You're going to be on farmland, which is a little bit more removed from the market. So your additional kilometers that you then have to travel then puts additional strain on your cold chain as well as your logistic costs. Just this time is not running. So then, in addition to that, we also have quite a high water usage, around about 250 liters for every kilogram of lettuce that's produced. That's typically the norm. Then there's also high pesticide and fertilizer use. One of the interesting things about producing leafy greens in a conventional environment is the rigorous washing process that the produce has to go through before it gets packed. So that means that there's a lot of bruising that takes place, and inevitably then also the produce's shelf life then as a result suffers because of that. Produce that come in from the land are quite dirty. They also have all kinds of other things on them, so large waste factor, 30 to 40%. And because it's normal, traditional manual farming, there's a high risk human error, mistakes that can be made. It's quite a low-tech way of farming. That means that there's not a lot of data logging, there's not a lot of on-site learning, and that puts additional difficulty on your meeting compliance. That's become more and more the norm today in the retail space. So we've thought that we've come up with some solutions, and that we address all of these issues with vertical farming technology. So enclosing it or being able to use this technology, you get a lot more plants in the same square meterage, so that now makes it possible to start farming in an indoor environment. Once you start doing that, you now have control over your climate, over your temperature, humidity, and you are now also on a much smaller footprint. Because you're on such a smaller footprint, you can now start considering being closer to your urban environments, maybe urban farming itself, or you could also be in a peri-urban environment, so that you then reduce your demand on your cold chain as well as logistics kilometers. We use very low water because we circulate the water. It's not water that gets fertigated and then goes to the plants. It's in a closed loop system. So we use as little as 10 liters for every kilogram of lettuce that we produce. Compare that to 250 liters of water for traditional. We also have a very, very low fertilizer usage, because all the fertilizer that we provide gets used by the plants in the closed loop system. And then there is also the opportunity, well, we don't use any pesticides, but there's also the opportunity to have no pesticides. So that reduces cost quite a bit as well. One of the advantages, but it's also a disadvantage of our product, is that it's a soft, tender leaf, as opposed to produce which is being grown for 3 months out in the field. It's more rigorous, more hard. Our produce won't go through the normal rigorous washing process at normal, but that's also an advantage because it's cheaper and shorter route. We don't have to wash any bugs or soil off the leaves. It's already a clean product. So then we also have a very, very small waste factor, 5%, but let's call it 10. Then we have an automated process where a lot of the controls that we have in place is automated, data logged, and we monitor that constantly, which means that reduces the risk for error. We haven't lost a crop in a year and a half, so we're happy with how the system works. And then our technology with data logging allows us to learn as we go on. If we make little mistakes, we can go see where we made those mistakes, and it makes traceability easy. And it also allows us to answer a lot of the questions, the compliance questions that is thrown our way from large retail guys. So there we have the challenges and possible solutions of what this technology provides. So just want to add to that is that this technology was developed in South Africa because we're South African people and we're in our own backyard, so we did it here. But we also realized that there is a bigger demand for this type of technology in other places in the world. In South Africa, we got relatively paradise for this type of farming. Land's not too much of an issue. We still got some water. You can still get into the city. So we understand that this is not the place in the world where this is the most needed. But if I look at our cost of production and our what we've done so far, there is definitely place for it even in South Africa. So just want to maybe just give you a little bit of a time frame. So in 2015, we came up with this idea and said, right, if you normally want to farm this stuff, then you're going to have to if you farm leafy greens, it's going to be all on a level area, and there's sunlight from above. So what typically does, people do vertical farming and they say, okay, well, how are we going to get more area in this closed environment? So they end up stacking on top of each other. So boom, 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 there's all your layers, but now we've cut the sun out. So now what we have to do is we have to put the LED lights back in. And now the cost of operation starts running away with us. So what we thought is, okay, well, how about if we just take this thing and we turn it the other way around, 90 degrees, and let the sun shine in. So the way to then is then we got the sun then to be able to pass over and align this thing in north-south orientation. So there's the timeline, 2015. Gideon, my partner, came up with this idea, madly enough, and then started doing some patents. 2016, pilot plant 1, pilot plant 2. Then 2018, we built the commercial unit, and then, okay, now we start this thing up and see what blows up, what doesn't work, fix what doesn't work. And so then once that was all done and we got something which is working, then we started doing tests with different cultivars, what works in our system, what doesn't work, which is the nutrient programs that we have to do. So then we did a whole lot of work to get the technology to work. So 2019 was a hectic year to do all of those things. But then we also did the one thing which we set ourselves the goal to do in the first place, is nobody can tell us, as far as vertical farms are concerned, anywhere in the world, what does it cost to run this thing? What does it cost per kilogram to make lettuce or spinach or kale or something like that? So everybody's got these ideas, but build this thing on a commercial scale, operate it, run it, test it. So we put in measurement everywhere. We put in all the distribution boards, electric power meters, water meters, everything required to be able to data log everything that we do so that we can go and benchmark this thing. Then, of course, Global Gap and all the other compliance have to come into place as well. So we've only got a few minutes, so I'm going to try and show you a little bit of what we do in the farm. I'm going to flip through some pictures, and just to make it a little bit less technical. So this is our farm. What we have there is we have a nursery, because we make our own little seedlings. And then we grow them for three weeks, and then after 3 weeks, they get planted out into the greenhouse, into these vertical pipes. Once they're in the greenhouse, around about 28 days, then they're done, and then we harvest as well. So we plant per row, and then we harvest per row as well. So we go through one side of the greenhouse, and then after 28 days, we start at the other end, and we keep harvesting and keep planting as we go. So it's a rolling production rather than a crop that goes in and grows and then comes off. So then we also have additional facilities, because once you build this thing, you also want to do value add. So you want to do your packaging, you want to have your cold room. What I didn't mention earlier is that lettuce is the one produce which retailers battle the most with to get it right. And, if Mrs. Housewife walks into the shop, to Woolies over there, and there's no lettuce on the shelf, and she turns around, she goes and buys the groceries somewhere else. And it's been made possible by the mall. So you've got Checkers and Pick and Pay and all these places also. It's no problem for them to just go to the next store. So the one thing that's difficult for everybody to get right is lettuce, and the reason for that is because it's a soft product, and it's got no shelf life, or very little short shelf life. So this facility then grows the lettuce and packs it as well. And then, of course, there's the plant to make all of it work. So just give you a little bit of background. We plant the seedlings in these little seedling trays that you see over there. And to make it work better for us, we've got this little biodegradable baskets that we use. These little baskets is so that we can handle the seedling without pulling it out by its leaves out of the plug, and that it also has a little cradle when it goes into the pipe and sits comfortably over there. In addition to that, it's also with the idea in mind for future automation. I'll get back to that later. So this is the little seedlings that we plant. We do them 2 at a time, because we can put 2 seedlings into each one of these little pods in the greenhouse. So those little pods that you see there, those are 2, 2, 2. Some cultivars don't like sharing, and then we'll just put 1. But, okay, we'll do 2 for those who don't mind sharing. So that's the nursery. Then in the greenhouse, we've got the pipe section. This grow tube has got these little pockets, and this is where we plant the little seedlings in. Then they grow for 4 weeks in this pipe until it's time to harvest. In the pipe, we pump water from the pump room down to the top, and then it cascades down the pipe from root structure to root structure, and filters down. So here you can see the little seedlings now sprouting roots, and that's now in the nutrient-rich water stream in the pipe section. That little blue plate is the little cup that the basket fits into, and when we harvest it with roots, cup, leaf, everything like that, and then we later on cut the roots off. I'll show you a little bit more about that. This over here has an infrared slider. I just want to go back to the previous one. In the greenhouse over here, we pump the water to the top, and then cascades down, as I said. Now, and what we do to control climate and temperature in the greenhouse is that we precondition the water. The water that we pump up to this is either cooled or heated, in our case, only cooled. And we're interested in keeping the root structure of the plant and the plant itself cool, not necessarily the whole greenhouse. So if you take an infrared shot of this, you'll notice over here, on the right-hand side, you'll see blue circulating, red stagnant. So you can see the temperature difference in the greenhouse once you start circulating the cool water. Then these vertical pipes that we have and the cool water filtering through the pipes and the air moving through the greenhouse also has a big radiator effect. So you can actually feel immediately when you walk into the greenhouse that it's much, much, much cooler when the pumps are circulating. All right, so just 1 or 2 more shots of the greenhouse and some of the produce before it gets harvested. So once we harvest in these crates. We harvest it with the roots and the little blue plate, everything intact, and we pre-cool before we do anything with it. There's a number of reasons for that, we haven't got time. So we have pack facilities. In the pack facilities, we cut the root structure off, then we pack the lettuce, the little blue plate gets recovered, and the rest goes for composting. So in the plant, the pump room, let's call it the pump room. There's a little diagram on the right-hand side over there, next to old Andrew looking all impressed with himself. There's 3 pumps. Pump number 1, 2, and 3 are at the bottom. The diagram's quite simple. Pump number 1 is the main pump, taking the water which is in the tank, pumping it to the plants in the greenhouse. In each greenhouse, there's 6 rows and 3 tanks in the basement. So there's 3 tanks, and there's 12 tanks in a 4 greenhouse. So that pumps water up to the top, and it just comes by gravity back to the tank again, where it gets filtered. Then pump number 2 is where we take the content of those tanks, send it to the fertigation machine, and put nutrients into the water on a constant basis. And then we also have pump number 3, the brown one at the bottom, which is sent it to the chiller to cool the water. So all the water that comes in our water supply gets pre-treated and we clean it. So we only top up our tanks with clean water, and then everything is measured and data logged. Temperature, humidity, EC, everything is monitored in the greenhouse and in the pump room and in the tanks. This over here is a shot of the pump room itself. There you can see the tanks on the left-hand side. That's one bank. There's another bank just like that on the right-hand side. And here in the middle, we've got our fertigation machine and a UV treatment plant, where we first filter all the water and then clean the water with UV as well. This is a very important part of what we do. Because of the high density planting, it's important for us to keep pathogens out of the plant. So this next slide shows on the left-hand side the nutrients in the 6 tanks on stands with little bundles around. Those are the nutrient tanks. This is from where we draw nutrients from, and that gets automatically put into the water. Our guys in the pump room do, however, go and manually take samples and write down what all the variables are, but it's just to check the system rather than as a primary thing. On the right-hand side, you'll see 2 silver pipes. Those are the cold water that circulate from the chiller plant outside, and the water then passes through heat exchangers. Heat exchangers is what's used to cool the water in those tanks once they go over a certain set point. And that means that we've got one chiller system outside which can cool all 12 tanks in the greenhouse or in the pump room without the water of those 12 tanks actually touching or mixing with each other. Right, so where does this fit? Where does this business work? So ideal partners for us, because we realized, and I call them partners, is because we won't end up selling the technology to somebody and say, well, there you go with God, give us some money and go, hope you do well. We realized in 2019, while we were operating and starting thinking, that a lot of our IP is not the patents that we own, but it's the knowledge that we've built up over the 12 months of running this thing is actually critical to the success of this thing. So we should actually rather view ourselves as a service business and not as a technology provider. Maybe we both. But so our ideal partners, and we will stay involved with the project, is people who are currently large producers of leafy greens, food services companies, and then also large retail companies. Then our ideal location, well, necessarily being on the farm is not that great. As I explained earlier, there's other benefits for us. So first prize would be in an urban environment. First prize would actually be right next to the DC, or distribution center for retailers. But urban environment, or failing that, peri-urban would be a good place for us to be. So here's some interesting numbers. Production capacity around about 50 tons for the unit that we've built, which is a standard unit, or we call it a standard unit. It's 4 greenhouses with all the facilities with it. The total cost of such a project is around about 40 million rand. Payback on that, 4 to 5 years. Our power usage, around about 1 kilowatt for every kilogram of lettuce that we produce. And our water usage, I mentioned earlier, around 10 liters per kilogram. So here are some interesting facts. This is stuff that nobody could ever give you before. And because we built a facility, because we ran it, these are the numbers that's now available for us to have a look at. So we realized that, okay, surprise, surprise, labor is our biggest cost, 36% odd. Then other thing is, the next thing that costs us the most money is our seedlings. little baskets, grow material, seedlings. Then packaging, logistics, energy, quite low because we make use of the sun. And then the rest of the stuff is not really. So then what's next for us? We've got, next up is LED research. So we've got inquiries from some northern climes where the daylight hours is much less than what ours. And although we do use the sun, in certain territories in the world, we can't say, listen, we're not going to use any LEDs at all. So we are starting to do quite a lot of work on LED research to see what the difference is that makes, the cost of it and the operational cost of it. So yes, we've spurred the whole idea about LED, and that's why we did what we did to let the sun in. But we realize also is that there's a place for that as well. But let it not be the only thing that the only source of light for us. So that's definitely the one thing that we're going to be working on next. And then the second thing is automation or robotics. Not necessarily that robotics is the way to go in Africa, but there's territories in once again, northern climates where robotics is what makes this feasible or not. Especially when you're looking at around about 36% of your total cost being labor, then robotics definitely makes sense. Not only from a cost point of view, but from a practical point of view. Certain parts of America, guys are telling us that, you know what, it's not so much that labor is expensive, it's that when we get a big snowstorm over here, we've got a week where nobody can come to work. It's just the roads are, so the stuff's on the shelf. So robotics is important to be able to get production going. So we've finished 4 minutes before the time's over. So I could have slowed down a little bit. But we look forward to getting some questions from you guys. Thank you very much.